What would happen if Earth woke up one morning to find two suns in the sky instead of one? Hello, and welcome to Smarter by Midnight, your tiny, quaint little library at the edge of the universe. Tonight, we're going to be looking at an alternate reality, one where the Earth has inherited not one sun but two. Just get relaxed, curl up by the window or your bed, and enjoy our little thought experiment. If you're having fun along the way, remember to subscribe or share this video with a loved one who likes to fall asleep to the wonders of the universe. Now, on Earth, a second sun would be impossible to ignore. Shadows would double. A skyscraper would cast twin silhouettes, splitting and merging as the suns moved. At times, they might stretch in opposite directions, creating geometric illusions in the streets. Fun fact: on Kepler 16b, sunsets happen twice in sequence, one star dipping below the horizon while the other lingers. Imagine that spectacle on Earth. Not one golden arc into darkness, but a drawn-out farewell as two suns trade places in the sky. The night sky would vanish. Stars, constellations, meteor showers, the Milky Way, erased by constant glow. Humanity would lose the very canvas on which it painted its myths. Orion, Ursa Major, the Pleiades, names passed down for millennia, would survive only in books and planetariums. Biology would feel the change instantly. Baby sea turtles today use the dim contrast of the moonlit horizon to find the ocean. With two suns lingering, every horizon would look bright. Entire species would falter in confusion. Culturally, myths would splinter. From Ra in Egypt to Apollo in Greece to Amaterasu in Japan, civilizations built religion on a single sun. Add a rival star, and cosmology rewrites itself. Some would see duality, some conflict, some balance, but never the old singularity. And for humans themselves, sleep would collapse. Our bodies depend on darkness to trigger melatonin. With no real night, insomnia would spread, and technology would step in to manufacture artificial cycles of rest. The double sunrise changes everything. Not just how Earth looks, but how it feels, how it sleeps, how it dreams. Shadows are simple under one sun. They fall in straight lines, growing long at dusk, shrinking at noon. Under two suns, they become chaotic. Buildings would project double outlines. Cars would stretch twin shapes onto the pavement. Even a person walking would carry two shadows, shifting as the suns crossed each other in the sky. Sometimes the shadows would overlap into darker bands. Other times they'd diverge, creating strange ghost images. Fun fact: photographers already simulate this by using two light sources in studios. The result looks unnatural, almost unsettling. Under two suns, the whole world becomes a photo experiment. Every object tagged with multiple signatures of light. Art and architecture would adapt. Painters might capture double silhouettes as symbols of modernity. Architects might design around shadow interference, ensuring buildings don't blind pedestrians with unpredictable glare. In sports, even a simple game of baseball or soccer becomes harder. Judging the angle of a ball is confusing when shadows point in two directions. The simple act of standing under the sky becomes uncanny, as if Earth itself forgot how light should behave. Urban life magnifies the change. Glass towers turn into beacons, flaring sunlight from two sources at once. Window coatings and reflective films become mandatory to prevent accidents. Drivers already struggle with glare. Now, intersections become dangerous zones, with doubled reflections bouncing off every surface. Fun fact: Las Vegas once had to redesign a hotel because its curved glass facade concentrated sunlight into a death ray, burning guests by the pool. Under two suns, every city would face the same hazard on a massive scale. Billboards and advertising adapt too. Designers switch from bright colors to muted palettes, knowing the suns will wash everything out. Neon signs and street lamps lose relevance. Why light a road when it never grows dark? Nightlife culture transforms. Cinemas and theaters thrive because they offer something rare: darkness. Clubs and restaurants market themselves as sanctuaries of shadow, selling not only entertainment but relief. The city becomes a paradox, brighter than ever, yet desperate for places where light cannot reach. Stars are humanity's oldest companions. They guided Polynesian sailors across oceans, inspired constellations, and became the foundation of calendars. Two suns erase them. Fun fact: the Polynesians navigated thousands of miles using only the stars, memorizing patterns that shifted with seasons. Without stars, their voyages would have been impossible. Under two suns, that cultural history would never have existed. The Milky Way would fade. Meteor showers would vanish from memory. Even the moon would pale, drowned in constant glow. Poets who once wrote about starlight would turn nostalgic, preserving in words what no one could see in the sky. Astronomy would be set back centuries. Telescopes on Earth rely on darkness to peer into the cosmos. With no night, only space telescopes would work. The ground-based observatories in Chile, Hawaii, and Spain, useless. Our connection to the universe, visible every night today, would be severed. And beyond science, there's the human soul. Psychologists already know that starless skies in modern cities can heighten anxiety. With two suns, the entire planet would share that disconnection. Night would not be a time of wonder, but a short-lived dimming, if it came at all. The double sunrise doesn't look the same everywhere. In the Sahara, the heat already pushes limits. With two suns, dunes might shimmer like metal, daytime stretching endlessly. In the Pacific, the horizon would hold two golden discs reflected on the waves, ships sailing between twin light paths. In the Arctic, midnight sun already blurs night and day. With two suns, darkness could vanish from the poles entirely. Fun fact: in Norway, the town of Tromsø experiences months without night each year. Locals report midnight sun insomnia, struggling to rest despite blackout curtains. Under two suns, the entire Earth would live in Tromsø-esque condition forever. Weather, too, changes in appearance. Clouds glow with doubled highlights. Rainbows double their arcs, one for each source of light. Skies at dusk become canvases of strange geometry, red and gold smeared in layers, a painter's palette made overwhelming. The Earth we know, with predictable rhythms of light and dark, becomes unrecognizable. How would people feel under two suns? At first, sunrises would draw crowds, tourists traveling to watch twin dawns rise over oceans or mountains. Photographers would document the surreal geometry of shadows and skies. Artists would reinterpret the world with new palettes. But all would give way to unease. Insomnia spreads. Glare becomes exhausting. Nostalgia for night grows acute. Parents tell children stories about stars they will never see. Museums host exhibits of the lost sky, recreating constellations in domed ceilings. Fun fact: already, planetariums in cities like Tokyo and New York attract visitors who want to see stars they cannot find outside. Under two suns, planetariums might become sacred, the only places where the true night sky is preserved. The human imagination adapts. Myths once told of a single sun may split into dual narratives. Two brothers, two rivals, two lovers circling forever. Cultures might anchor themselves in twilight, worshipping the fleeting minutes when both suns sink at once. But behind the stories lies fatigue. Or at first, weariness later, and then adaptation. Humanity learns to live in endless day, but not without cost. The sky is different. Shadows split, cities shimmer, stars vanish, myths fracture. Humanity marvels, then struggles. But these are only the first consequences. If the sky is different, the earth beneath it must be too. Two suns do not just change how the world looks, they change how it works. Heat rises. Oceans shift. Storms intensify. And so, after the double sunrise comes something more dangerous, a world on fire. We put a great deal of care into making these long journeys for you, weaving science, imagination, and storytelling into a space where curiosity can wander. If you find value in what we do, consider subscribing and supporting the channel, so we can keep bringing you stories like this one. Now, let's step into a world where Earth lives under two suns. Stand in a forest, where morning should filter soft beams through the canopy. Now every beam is doubled. Branches cast two webs of shadow, slightly offset. The ground looks layered, like someone has traced over the same sketch with a second pen. Leaves flutter, and instead of a single dance of light and dark, two competing rhythms play on the forest floor. Walk into a canyon. Normally, cliffs give you a sharp line of shade where one side is dark, the other blazing. But with two suns, the canyon never agrees. Shadows fold and unfold, never sharp, never stable. Explorers lose their sense of direction because the light no longer tells the truth. Even simple things change. Try to read a book outdoors. Each page now holds two faint shadows of your own hand, letters outlined twice, eyes straining to find a single focus. Artists find their work distorted. Painters of landscapes realize perspective doesn't make sense when every object splits into two outlines. Photographers lift cameras only to discover their subjects look haunted by ghost images. Children laugh at their twin shadows, chasing them across playgrounds. But parents notice the confusion in their steps, how depth looks different, how balls roll in unexpected arcs under conflicting light. For architects, the math of angles must be rewritten. Bridges, towers, stadiums, all designed with a single sun in mind, now wear a double face. In ancient times, shadows were clocks. Sundials ruled empires. Farmers read the length of the dark to know when to sow and harvest. But here time breaks. Two shadows pull apart like quarreling siblings, and no dial can keep up. A world built on the rhythm of one star suddenly has no clean measure of day. Shadows, once loyal to a single master, now serve two. And in their disobedience, they reveal the truth. Earth itself is caught between powers it cannot reconcile. In the heart of a metropolis, the suns carve contradictions. Glass towers flare white on one side, amber on the other. Streets blaze with reflections, two glares colliding at different angles. Billboards designed for sunlight now burn unreadable. Solar panels work overtime, but some fail from heat overload. Commuters pour out of subways squinting, wearing improvised visors, welding masks, even cloth pulled from drawers. People blink like owls dragged from their nests. Some rush into shaded arcades. Others linger in doorways, unable to stop staring upward. In offices, blinds stay shut all day, yet rooms are still too bright. Air conditioners grind harder. Power grids hum at their limits. Some workers cheer. Solar energy floods the grid like never before. But others groan. Servers overheat, machines break down, headaches spread. Schools struggle to teach lessons when students keep gazing at their doubled shadows. Teachers remind them to focus, but even the teachers sneak glances at the impossible sky. Playground games mutate. Children point their twin silhouettes at each other, pretending to duel. Others hide indoors, unsettled by the endless light. Religious groups gather in plazas, some calling it a miracle, others warning of doom. Journalists climb rooftops to record the doubled dawn. Drones buzz above, catching footage of a city dressed in two overlapping masks. The internet floods with images, memes, panic, joy. Humanity processes in the only way it knows. Together, chaotically, loudly. And beneath the noise, one fact lingers. A city is not meant for two suns. Concrete soaks up heat faster than before. Asphalt softens. Nights no longer cool the streets. Cities that once cooled at midnight stay fever hot, simmering long after the last worker goes home. Urban life changes first, because here, the sky has nowhere to hide. You wait for night. Surely the stars will return. But darkness arrives like a wounded animal, late, weak, incomplete. The first sun dips low, scattering red fire across rooftops. The second follows slowly, stretching twilight like pulled silk. Together they refuse to vanish, always leaving a trace of glow. By the time both are gone, the sky is not black, but rust-colored, dim, restless. Stars appear only as pale freckles, faint, forgettable. The Milky Way no longer paints itself overhead. Astronomers despair. Telescopes that once captured galaxies now see only haze. Amateur stargazers lose their hobby. Lovers who carved constellations into memory can no longer find them. A species that has always told stories by starlight finds the stories erased. Sleep falters. Circadian rhythms, tuned to contrast between day and night, collapse. Insomnia rises. Children stay restless long after bedtime. Adults wake at odd hours, confused by faint light bleeding through curtains. Factories test artificial dark zones, with blackout panels to simulate true night. Black becomes a luxury. Culture shifts. Festivals once tied to full moons lose their anchor. Midnight ceases to be meaningful. Nightclubs rename themselves shadow hours, because there is no true night left to own. Poets write elegies for darkness, the lost half of the human day. The stars are silent. Humanity lies awake. And the earth turns under too much light. Sail to the Pacific. Two suns paint the ocean with two parallel streaks of fire. Waves catch each reflection separately, making the sea look like molten braids of gold and copper. Sailors lose their sense of direction. Compasses suddenly less useful when the sky itself is confused. Fly to the Arctic. Snow no longer glows pale blue, but orange and yellow at once, bleeding into unnatural hues. Ice that should linger through summer shrinks twice as fast. Polar bears hunt on thinning floes, their silhouettes doubled on the water's surface. Cross the Sahara. Sand turns from gold to a searing white blaze. Shadows of dunes overlap, confusing travelers. Heat haze multiplies. Nomads who once read the desert like a book now find the letters scrambled. Stand at the Amazon's edge. The canopy floods with light, vines glowing unnaturally bright. No corner of the jungle rests. Even predators cannot find darkness to hunt in. The rhythm of life dissolves into endless glare. Everywhere, Earth's face is rewritten by the presence of two suns. At first, billions stare upward, phones raised, mouths open. For a few days, it feels like wonder has returned to the species. Something too big to ignore, too strange to explain away. Then fear. Sleep deprivation grows. Heat lingers. Crops begin to act strangely. Scientists warn of long-term changes. The novelty fades into uncertainty. And finally, resignation. Humanity adapts. Curtains grow thicker. Cities invent artificial nights. Children born into the new sky never miss the old one. For them, two suns are normal, and true night is just a story. But for those who remember the single sunrise, there is grief. A quiet loss. The stars are gone, and with them, a mirror humanity once used to measure itself. The act ends with a question. If the sky itself can change, how long before the ground beneath us must follow? Noon arrives and the sky stops pretending to be kind. At first you think it's like any other hot day, air bright, sidewalks shimmering. But then both suns crest high enough to overlap their strength, and the light turns from illumination into pressure. It doesn't lie on your skin, it pushes. Every square inch of you can feel the math. More photons, more heat, less relief. Roads fold first. Asphalt softens into a slow, dark tide that clings to tires and remembers footsteps. City crews scatter sand to keep buses from sinking at intersections. Crosswalk paint blurs, white stripes liquefying into grey smears. On an overpass, a guardrail warps just enough to look like it's breathing. In kitchens and factories, thermometers break old records by late morning and keep climbing. Warehouse floors become ovens with forklifts. Cold storage rooms triple their humming and still sweat. The air has that metallic tang of electricity working too hard. Your phone's weather app doesn't have a word for this. Heat index was designed for the courtesy of one sun. Under 2, shade is only half a promise and breeze is an insult. You can find a shadow, yes, but the second light leaks around it, soft, hot, impolite. So even relief has edges of burn. Hospitals feel it first as noon keeps regaining its strength, hour after hour. Triage tents bloom outside ER entrances. Medics carry ice like treasure. Cool, not cold, they say, because the shock of true cold on a too hot body can betray the heart. Volunteers soak towels in kiddie pools and drape them over elders' shoulders. Someone brings a stack of cheap fans and an extension cord long enough to trip over. The fans move air that feels like it came from a dryer. People smile anyway. Kindness counts in any climate. On rooftops, satellite dishes glint white, then amber, then almost blue-white as they rotate into the gold sun's beam, and then the redder one. Tar turns to gloss. Pigeons learn quickly which parapets fry feet, and which merely sting. Gardeners pour water into soil that exhales steam. Leaves cup and curl like hands trying to shield themselves. Out on highways where heat usually shimmers in gentle mirage, the second sun lays a second shimmer over the first, distortion layered on distortion. Distant trucks swim, like fish in boiling glass. Drivers slow, because nothing stays where your eyes expect it to be. The lane lines wiggle, even when you know the paint is straight. The mind tires before the muscles do. On coasts, piers crackle under heat and glare. People wade into water that used to feel like forgiveness, and find it warmer than memory. The surface rejects bodies like a crowded room. Children shriek, the happy kind, but their parents squint and keep their hats on and glance at the time. Everyone talks about sunscreen, like it's a verb with a moral attached. Did you sunscreen? You need to sunscreen again. In the farm belt, greenhouses shade their glass. Open fields don't get that luxury. Irrigation pivots turn, but the water flashes into glitter before it sinks, droplets vanishing in the air. Farmers walk rows and see leaves bleaching at the tips, a pale warning. Some crops race ahead. Too much light and warmth spurs them into frantic growth. But the fruit inside grows watery, uncommitted, the plant confused about what to do with all this gift that feels like a threat. Animal life negotiates. Cows crowd barn shadows. Horses stand hip to hip under a single tree that leaks light like a sieve. Bees stay furious, busy, accelerated, then drop sudden and still, overheated mid-flight. In city parks, dogs remember that their paws are made for many things, but not this. Power grids glow. Solar farms report yields no one believed were possible outside spreadsheets, then trip off to protect themselves. It's a strange new problem. Too much good, turned bad by excess. Electric companies beg for staggered demand. Emails go out. Set thermostats to 26 degrees Celsius. Close blinds. Check on neighbors. The emails arrive at the speed of light. Compressors answer slower. Somewhere a transformer pops with a sound like a drum hit. The neighborhood behind it holds its breath and counts to see if the lights return. People invent rituals quickly. Wet bandanas in freezers. Cold packs in pillowcases. Shower shoes in locker rooms turned community cooling centers. A grandmother in a tower block teaches a line of kids how to fold newspaper into hand fans. Wrist, neck, ankles. Cool here, she says, the places where your pulse carries the heat away. They listen because she is a person who has lived through other kinds of noon. The difference between hot and punishing is time. Under one Sunday, noon has a peak and then it relents. Under two, the plateau lingers. Noon becomes a broad table where the day sits and refuses to rise. Lunch breaks stretch not because bosses are kind, but because bodies revolt in small ways. The 5-minute pause becomes 10, then a quarter hour. Coffee is replaced by salt and water. Ambition recalibrates. Surviving until evening counts as productivity. In Delhi, the air wraps the city in a wet blanket and squeezes. In Phoenix, it's the opposite, dry and surgical, like being wrapped in a heated sheet of paper. In Cairo, wind tries to help and fails, arriving with a mouthful of dust. In Lagos, the rain comes hard and hot, then leaves even harder heat behind. Every city discovers its own definition of unbearable. Clock towers keep ringing, but people live by other signals. The first metallic groan of rails on a sun-struck bridge, the moment the river begins to smell of warm algae, the exact minute a square of shade from a building nudges over a bus stop. Commuters migrate as shadows move. Planters and street vendors stake claims not on corners, but on predicted slices of cool. At construction sites, safety officers become priests of shade. Work-rest cycles rewrite themselves. 15 minutes on, 30 off, more water than pride. Helmets bake. Cranes moan. Concrete cures too fast, spiderwebbing with hairline cracks that promise futures no one can afford. People set alarms not for meetings, but for rehydration. Birds change their routes. Some species learn the language of awnings and overhangs. Others go high, riding thermals born twice as strong. On a strange noon, a hawk simply stops flapping and trusts the rising air to hold it like a hand. It glides, precise and exhausted, a master in a training program it didn't ask to join. Heat touches sound, too. Streets buzz a key higher, like a choir tight with nerves. In heat like this, arguments start easier, laughter comes in bursts and dies, music drifts from windows less often. The city becomes a set of low murmurs punctuated by sudden shouts, as if even noise has to pace itself. Midway through the afternoon, you learn new physics. A metal bench can be both seat and stove. A steering wheel can brand. A faucet can deliver water that fails to cool skin. You map your home by the safe handles and the treacherous ones. You step lightly on tile that remembers the morning sun. You check on plants like they are relatives recovering from surgery. Somewhere, researchers in windowless rooms speak in a language the rest of us will learn soon enough. Albedo, radiative forcing, spectral distribution. They argue about which interventions might be possible and which are fantasies. They make models that cough out colors, the blues and reds of peril, and pin them to maps that look, unhelpfully, like our old world. Out here at street level, you don't need colors to tell you what is happening. You can smell it in tar, taste it in the air, see it in the way a child presses her cheek to a cool floor and refuses to move. Late afternoon, an ambulance moves slowly, siren polite, lights oddly dim in the flood of day. Paramedics step out in caps and mirrored glasses, carrying the sacred trinity of this new era: water, shade, patience. They speak softly to a man whose pride is stronger than his heart until, eventually, pride agrees to ride. On the radio, a weather voice tries metaphors, like standing in front of an open oven, like a hairdryer on high, like a kiln. None of them are quite right. The oven metaphor assumes you can take a step back and close the door. The dryer metaphor assumes the heat stops when you push a button. The kiln metaphor is close, with its promise of transformation, clay to ceramic, but the city does not want to be fired, and people are not pots. Sunset used to be mercy. Today you learn that mercy can be delayed, and still called mercy. The gold sun staggers toward the horizon. The red lingers, stubborn. The temperature drops in hesitant increments. Relief arrives like a late friend. Welcome, forgiven, still late. People come outside not because it's pleasant, but because it is, at last, survivable. They stand on balconies and breathe. They count fire escapes and say hello to neighbors they have never seen in daylight, because daylight used to behave. At last, both stars sink. Heat clings to concrete. It takes all night to unlearn what noon taught it. Windows stay open. Fans turn in windows like lazy propellers. Some people sleep on floors. Some sleep not at all. Somewhere, an infant finally stops crying in the moment when the room drops 1 single degree, and a mother prays to any power listening that the child does not wake when it rises again. The night is short. Dawn is impatient. Tomorrow will try again to be livable. 2 suns will argue over how bright the world should be, and the world will answer with the all-too-human chorus it has been practicing since the first blaze doubled. We can't turn you off, so we learn to bend. When Earth is exposed to the radiation of 2 suns, the oceans become one of the first systems to tip into crisis. Water absorbs heat slowly, but once it does, it keeps it. With 2 sources of solar input, surface temperatures climb beyond historic norms. The poles, once protected by vast ice sheets, begin to erode at unprecedented speeds. Greenland and Antarctica no longer melt over centuries, but over decades. This transformation would redraw the world map. Low-lying nations like the Maldives, Tuvalu, and Bangladesh would see coastlines swallowed within a generation. Iconic cities, New York, Miami, Shanghai, Lagos, would spend billions building seawalls only to discover those walls were already obsolete. The oceans themselves would not remain passive. Currents like the Gulf Stream and the Kuroshio are driven by delicate gradients of temperature and salinity. Extra heat disrupts these gradients. The conveyor belt that moves warm water north and cold water south could stall, reshaping weather across continents. Northern Europe might paradoxically grow colder if circulation collapsed, even as the tropics burned hotter. Marine ecosystems respond poorly to such shocks. Coral reefs bleach under today's warming. Under 2 suns, the bleaching would be near total. Fisheries collapse. Plankton blooms may surge, then vanish. The base of the ocean food web, once stable, becomes erratic. Humanity would face not just rising seas, but collapsing fisheries. Two pillars of civilization destabilized at once. With two suns overhead, the planet's atmosphere would load with energy at levels never recorded. More energy means more violent weather. Hurricanes would become stronger, not just by category, but by endurance. Instead of a storm intensifying for a day before weakening, it might sustain peak strength for weeks, fueled by oceans that never cool. Typhoons could circle basins in endless loops, slamming coastlines again and again. The jet streams that steer weather would lose their traditional boundaries. With heat pouring in from two angles, the polar jet could buckle, pulling frigid air south one week and roasting heat north the next. Weather maps would look unrecognizable, streaked with erratic flows and storm tracks. Deserts would expand. The Sahara could swallow the Mediterranean basin. The American Southwest would creep toward the Great Plains. Regions once fertile would dry into scrubland. At the same time, some rainforests might collapse into savannas as constant light disrupts their moisture cycles. In short, the stability of seasons disappears. Agriculture, long tied to predictable rains and frost lines, would be forced into artificial environments. What was once bad weather becomes a permanent condition. Eventually, parts of Earth would cease to be habitable at all. The equatorial regions, already warm under one sun, would transform into zones of lethal heat. Wet bulb temperatures, a measure of heat plus humidity, would exceed the limits of human survival. Simply being outdoors for more than a few hours could be fatal. Humanity would retreat toward the poles. Canada, Scandinavia, Siberia, Patagonia, and Antarctica would become the new frontiers. Croplands would shift north and south, while equatorial nations faced depopulation and collapse. Migration on a scale never seen in history would begin. Billions would move, not by choice, but by necessity. This reorganization of habitability would cause geopolitical upheaval. Borders would be stressed. Nations that had once been peripheral would become central. Russia and Canada, with vast northern lands, would suddenly hold the most valuable real estate on the planet. The scramble for survivable territory would be as consequential as any war. In time, new belts of life would emerge, not evenly distributed, but concentrated around the mid-latitudes of what used to be inhospitable terrain. Civilization would not end, but it would migrate. Earth would become a planet of refugees chasing shade and cooler air. Faced with these conditions, humanity would not sit idle. Technology, already advanced, would be forced into emergency overdrive. Cities would redesign themselves as reflective landscapes. White paint, mirrored glass, and high-albedo materials would attempt to bounce sunlight back into space. In wealthier nations, skyscrapers would be covered in adaptive skins that change color to reflect excess heat. Streets might be lined with solar canopies, doubling as shade for pedestrians and power plants for the grid. Some responses would move underground. Subterranean neighborhoods, connected by transit, would offer relief from endless glare. Blackout districts, entire blocks covered with light-blocking membranes, would simulate night for people whose bodies could not cope with 24/7 brightness. Geoengineering proposals would leap from theory to necessity. Giant orbital shades might be deployed to block or redirect sunlight. Aerosol injections into the upper atmosphere could increase reflectivity, though at the cost of unpredictable side effects. Even massive artificial clouds, engineered swarms of reflective particles, might be tested. Agriculture would change fundamentally. Crops would move indoors, grown in climate-controlled towers and hydroponic domes. Genetic modification would produce plants capable of thriving under extreme light and heat. Farmers who once sowed under open skies would manage crops like technicians in labs. Energy, paradoxically, would become abundant. With two suns, solar power would achieve yields unimaginable under a single star. But the challenge would not be power supply, it would be survival. Cooling demands, food systems, and water treatment would consume the energy as fast as it was harvested. The human effort to adapt would not be uniform. Wealthier nations would deploy orbital technology and underground cities. Poorer nations, trapped in the burning equatorial belt, might collapse before adaptation was possible. Inequality, already stark, would deepen into a planetary fault line. Earth under two suns is not just hotter. It is unstable. Oceans rebel, storms intensify, deserts grow, and entire regions vanish beneath rising seas. Humanity fights back with walls, mirrors, and machines. But no adaptation can disguise the truth. Two suns mean a new planet. And if the environment reshapes itself so quickly, then life, all life, from plants to insects to humans, must reshape itself too. Plants are the first to feel the change. They cannot flee, they cannot hide. They stand rooted beneath the sky, absorbing whatever light the heavens decide to give. And when that sky contains not one, but two suns, the plant kingdom becomes the front line of survival. At first glance, it seems like a gift. More light means more energy, and plants live by light. Wheat, rice, corn, every blade of grass, all of them capture sunlight and transform it into food. Double the light, double the harvest, right? Not exactly. Every plant has a limit, a threshold where photosynthesis begins to shut down, like a laptop overheating under too much strain. Farmers already see this today. Tomato growers, for instance, often cover their greenhouses with shade cloth during the height of summer. Without that protection, the plants don't flourish, they scorch. And what happens in a greenhouse in July would happen everywhere, every month, under two suns. Imagine walking through a cornfield in Kansas. For a few weeks, the stalks grow taller than you've ever seen, soaking up the flood of light. But then the leaves begin to yellow at the edges. The ears form strangely, kernels uneven, as if the plant is confused about whether it has been given a blessing or a curse. Plants do have defenses. Many already make their own sunscreen. Desert wildflowers in Arizona produce flavonoids, compounds that work like tiny sunglasses inside their tissues. Alpine plants in the Himalayas grow silvery hairs that reflect sunlight away. Even here on present-day Earth, survival in harsh environments depends on clever chemistry. Under two suns, those tricks wouldn't be optional. They'd be universal. Wheat, rice, and soy would need to be bred, or more likely engineered, with their own built-in sunscreen. Picture fields of wheat that no longer shimmer golden, but glisten faintly silver, every stalk covered in reflective hairs designed to scatter away radiation. A farmer in Nebraska might look out and see a landscape that resembles a mirror more than a crop. In this world, science would do what nature once did slowly, rush evolution into the service of survival. And color itself might change. Some plants already produce pigments like anthocyanins to cope with stress. They turn leaves purple, red, or even black. The purple shamrock, a delicate houseplant today, thrives under bright light because of its violet shield. In labs, NASA has experimented with red lettuces for space agriculture, since their pigmentation makes them hardier under artificial light. Multiply those traits across entire ecosystems, and Earth's green face would darken into violet. Forests could glow maroon in the haze of sunset. Rice paddies might shimmer crimson. The old phrase, the green earth, would vanish from poetry. Children would grow up believing the planet was always purple, always dark-leaved, always forged beneath the twin glare. Agriculture would never be the same. Delicate leafy greens, lettuce, spinach, herbs, would fail outdoors within days, crisped by the relentless light. Hardy grains like sorghum or millet might persist longer, but even they would need help. Farmers would turn to indoor vertical farms, not as experiments or novelties, but as the backbone of civilization. We already see hints of this future. In Singapore, stacked greenhouses grow strawberries under glowing pink LEDs. In New Jersey, warehouses produce lettuce in climate-controlled towers. Right now, those projects feed niche markets. In a two-sun world, they would feed nations. Skyscrapers could double as food factories, their windows sealed, their insides lit by carefully tuned lamps. Human-made suns that give plants exactly what they need, no more, no less. But not every society, would be able to make that transition. Wealthy countries might pour trillions into bioengineering and vertical farms. Poorer nations, especially those already near the equator, could see their agriculture collapse completely. Entire regions might go from breadbaskets to barren zones within a generation. The global map of food would be rewritten. It's not just farms, either. Wild ecosystems would face turmoil. The Amazon rainforest, today one of Earth's richest cradles of life, relies on layers of shade, towering canopies, filtered light, cool understories. With two suns blasting from different angles, that shade evaporates. Plants designed for dim light would vanish. Orchids, ferns, mosses, whole families gone in decades. The jungle might thin into something closer to savanna, its intricate web unraveled. Grasslands, on the other hand, might thrive. Grasses are tough, flexible, able to take punishment. Many of them already use a specialized form of photosynthesis called C4, which is more efficient in hot, bright conditions. Corn, sugarcane, and sorghum use it today. Scientists believe C4 photosynthesis evolved millions of years ago when Earth was hotter and brighter than it is now. In a two-sun world, C4 plants would surge ahead, perhaps becoming the dominant life form across continents. Imagine savannas stretching across Europe, prairies pushing into Asia, grasses replacing forests in North America. At the poles, something different happens. Algae that once thrived under seasonal light cycles would face continuous bombardment. Some would collapse. Others might bloom uncontrollably, turning the Arctic Ocean into swaths of green soup. Polar summers already trigger blooms, so dense they can be seen from space. Under two suns, those events might last year-round, choking entire ecosystems. And then there's the aesthetic side of it. Walk through a city park in this world. The grass isn't green, it's a dusky purple. The trees glimmer with silvery fuzz. The flower beds glow darker than you remember. Even the vegetables at the market look uncanny. Carrots with black tops, cabbages with violet leaves, apples with skins tinted the color of plums. Children would never know that food once came in shades of green. Houseplants, too, would adapt. The beloved fiddle-leaf fig, the monstera with its split leaves, the peace lily, all would wilt under the new sky unless re-engineered. Instead, homes might be decorated with squat, silver-leaved specimens designed to endure the double glare. Gardening as a hobby would look more like running a lab experiment than tending a window box. People would trade tips not on watering, but on which pigment-boosting supplements to spray under artificial night. And while plants are silent, their struggle would echo everywhere. When crops fail, humans starve. When forests collapse, the atmosphere wavers. When grasslands spread, herbivores follow, predators follow them, and ecosystems reshape themselves. The story of two suns is not only about human cities or technology. It begins in the leaves of plants, in the simple chemistry of light and carbon dioxide. Consider this. Today, less than 1% of the sunlight hitting Earth is captured by plants for photosynthesis. The rest reflects, scatters, or warms the air. Add another sun, and that ratio doesn't just double, it destabilizes. The energy budget of the entire biosphere tips off balance. Plants scramble to adjust, but their timeline is evolutionary. Ours is generational. We feel the shortage long before they find their answers. And yet, life is stubborn. Even in this scenario, green, or purple, or silver would not vanish. We know this because life has done it before. After the asteroid that killed the dinosaurs, forests regrew. After ice ages, tundra gave way to meadow. Even now, on volcanic islands smothered in ash, plants claw back within years. Given two suns, life would twist and bend. It might look alien, but it would endure. So picture it again. A wheat field shimmering not gold, but metallic silver. A rainforest turned maroon. A city garden filled with plants that look more like sculptures than living things. Humanity would eat differently, live differently, even see differently. The color green, once a symbol of life itself, might become rare enough to feel nostalgic. Plants would survive. They always do. The question is whether humanity could survive with them, or if we would end up building entire artificial ecologies to replace what two suns burned away. This is the quiet revolution of a doubled sky. Not thunder, not fire, but the slow, relentless shift of leaves. And as plants change, animals must follow. Because when the forest loses its shadows, when the night no longer falls, when the rhythm of light no longer pauses, the animal kingdom must face the same question the plants already answered. How do you live when the world never goes dark? If plants are the first to struggle under two suns, animals are not far behind. Unlike plants, they can move, hide, or hunt. But every creature on Earth, from insects to whales, is wired to the rhythm of day and night. Break that rhythm, erase the night, and the animal kingdom enters uncharted territory. Consider the owl. A hunter of darkness, its enormous eyes are tuned to gather every scrap of moonlight, every faint glimmer of starlight. In a world where night never fully comes, the owl is out of place. It launches from its perch, wings silent, but the prey sees it coming, lit by the second sun's lingering glow. Generations of adaptation are undone in a single season. Populations collapse. Bats face the same fate. They emerge at twilight, guided not only by echolocation, but by a landscape softened into shadows. With constant glare, their advantage vanishes. They circle street lamps and vanish into exhaustion, unable to find darkness to call their own. Fireflies tell an even sadder story. Their entire mating ritual depends on flashing lights against the backdrop of night. Two suns erase that backdrop. Males flash, females respond, but the sky is never dark enough to see the signal. One generation, maybe two, and fireflies go quiet. A summer evening that once glowed with sparks becomes silent, another tradition stolen by light. But not all animals lose. Some gain. Cats, big and small, are twilight hunters. Domestic cats prowl suburban yards at dusk. Lions stalk the Serengeti as the sun drops low. Under two suns, dusk never ends. Permanent twilight means predators can hunt all day long. Imagine lions no longer resting through midday heat, but pacing under an eternal glow. Their prey, zebras, gazelles, wildebeest, never get a break. Populations shift. Predators thrive, at least for a while, until prey numbers dwindle and balance collapses. Birds face confusion of a different kind. Many species migrate by stars. The North Star has guided geese and warblers for millennia. Remove the stars behind a veil of constant brightness, and the compass is gone. Flights go astray. Birds crash into cities, circle endlessly, or fail to leave at all. A migration that once spanned continents becomes chaos. The same holds true for sea turtles. On Earth today, hatchlings crawl toward the brightest horizon, usually the moonlit ocean. Already, artificial lights in coastal towns lead them astray. With two suns lingering even after dusk, every direction looks like the horizon. Thousands would scurry inland instead of out to sea, their ancient instincts betrayed by a sky that no longer plays fair. Whales, too, would be lost. They sing and navigate partly by the stars above. With no stars visible, their journeys falter. Pods might strand themselves more often, mistaking coastlines for open water. Entire migration routes could collapse, starving populations that depend on seasonal feeding grounds. And then there are the insects. Many of them, like moths, rely on light for orientation. Today they circle lamps, confused. Under two suns, there is no away from the light. Migrations of monarch butterflies, already fragile, could disappear. Pollinators might falter. With plants changing, insects would change too, some adapting to new diets, others vanishing altogether. Fun fact: there's a species of beetle in Africa that navigates by the Milky Way. Researchers placed them in a planetarium, and sure enough, when the stars were switched off, the beetles wandered aimlessly. In a two-sun world, the Milky Way would be invisible. Those beetles, and anything like them, would lose their compass. Humans might step in, building artificial darkness reserves, just as we build wildlife reserves today. Picture a national park not defined by rivers or mountains, but by black domes stretching over forests, blocking out the suns to create night zones. Inside, owls, bats, fireflies, and nocturnal insects might cling to survival. Outside, endless day rules. Domesticated animals would change too. Cows, sheep, goats all suffer stress and heat. Farmers already use misting systems, shade shelters, and altered grazing schedules to cope with hot summers. Under two suns, those strategies would be permanent. Dairy cows might spend their lives indoors under artificial night, milked by machines, never grazing again. Chickens, already sensitive to light, would have their laying cycles disrupted. Farmers today use carefully timed lamps to control egg production. In a double-sun world, controlling that cycle would mean living in permanent blackout barns. Pets would feel it too. Dogs pout more, cats sleep in cool corners. Even aquarium fish could be stressed by the extra glare unless tanks were shielded. Zoos would need to build shaded, cooled enclosures for animals that evolved under gentle nights. Pandas, polar bears, even elephants would need artificial darkness to mimic the world they once knew. The ocean would not escape. Plankton, the foundation of marine food chains, rise and fall with light cycles. With two suns, that vertical migration might be disrupted. Fish that feed on plankton would struggle. The chain continues upward. Tuna, sharks, dolphins, each link stressed by the break in rhythm. Some animals might adapt in surprising ways. Over generations, new pigments could evolve, much like in plants. Lizards might develop reflective scales. Birds could grow darker feathers to shield themselves. Even mammals might change. Fun fact: reindeer in the Arctic already see in ultraviolet, a trait that helps them cope with low winter sun. In a two-sun Earth, new visual systems could emerge, tuned not to faint light, but to overwhelming brightness. Humans, of course, would watch this unfold with fascination and fear. Zoos would become places not of entertainment, but of remembrance. The last dark enclosures where nocturnal creatures still thrive. Documentaries would play old footage of starry skies, firefly-lit meadows, owl hunts in the night. Children would grow up watching those films the way we watch black and white movies. Curious, but disconnected from a world that no longer exists. The collapse of nocturnal life would reshape ecosystems in ways hard to predict. Remove bats, and insect populations explode. Remove fireflies, and certain plants lose pollinators. Remove migratory birds, and pests spread unchecked. Ecosystems are chains, and when night vanishes, many of those chains break. Yet life adapts. Always. Some species would learn to hide underground during the constant glow, emerging in the rare hours when both suns slip below the horizon together. Others would learn to live inside caves, hollow trees, or beneath thick vegetation. Evolution would favor creatures that could carve night out of day, even if only for moments. Picture a fox, not of our Earth, but of the double-sun Earth. Its eyes smaller, its coat darker, its behavior changed. It digs deeper dens, emerges only briefly, hunts quickly, and retreats again. It does not need night to thrive. It invents its own. The animal kingdom would not vanish under two suns. It would mutate, shift, reinvent itself. But much of what we know, the call of owls, the flash of fireflies, the great migrations guided by stars, would fade into memory. And in their place, a new rhythm would emerge. The rhythm of a planet that never sleeps, where day is eternal, and survival belongs only to those who can endure the light. If plants adapt slowly, and animals stumble awkwardly, humans are caught somewhere in between. We are clever enough to resist, but fragile enough to feel every consequence. And under two suns, our bodies become experiments in survival. The first change arrives in our sleep. For millions of years, human biology has been tuned to a 24-hour rhythm of light and dark. When light floods the sky, the pineal gland in the brain shuts off melatonin, the hormone that makes us drowsy. When darkness comes, melatonin flows again, coaxing us into rest. With two suns, that cycle collapses. True night barely exists. Melatonin production plummets. Insomnia becomes normal. Fatigue spreads like a contagion. We already see hints of this in cities, where light pollution erases the stars. People living under neon skies often report trouble sleeping, higher stress, and mood disorders. Under two suns, this wouldn't be an urban issue. It would be planetary. The solution might come in the form of technology: blackout pods, sleeping helmets, entire bedrooms designed like sensory deprivation tanks. People would have to engineer darkness just to dream. Then comes the skin. Double sunlight means double ultraviolet radiation. Even today, UV exposure is one of humanity's constant enemies, causing cancers, burns, and premature aging. Airline pilots, who spend long hours at altitude, already face double the melanoma risk of the general population. Now imagine that risk applied to everyone everywhere. Sunscreen becomes as essential as water. Shade becomes currency. Over generations, humans evolve thicker skin, more melanin, darker complexions across all latitudes. In a sense, the entire species tans permanently. Pale skin vanishes, not by fashion but by necessity. Eyes adapt too. Glare becomes unbearable. Sunglasses are not accessories anymore. They are survival tools. On Earth today, almost 64% of adults already wear glasses of some kind. In a two-sun future, that number approaches 100. Children receive polarized goggles the way they receive vaccinations. And slowly, over centuries, human eyes might darken, irises shifting toward brown and black to absorb less stray light. Fun fact: reindeer in the Arctic undergo seasonal eye color changes. In winter, their eyes turn deep blue to catch scarce light. In summer, they shift to gold. It helps them survive under extreme cycles. Humans under two suns might undergo similar changes over millennia. Adaptive eyes that shift color depending on which star dominates the sky. But perhaps the strangest challenge is inside us. Vitamin D, produced when sunlight touches our skin, is a fragile balance. Too little sunlight and bones weaken. Too much sunlight and vitamin D turns toxic, damaging kidneys and the heart. In today's world, northern populations often lack vitamin D and take supplements. Under two suns, the opposite becomes true. Hypervitaminosis D could become as common as the common cold. Doctors would prescribe shade and darkness the way they once prescribed cod liver oil. Heat compounds everything. Our sweat glands, our circulatory systems, our tolerance for heat stroke, all were designed for a single sun. With two, outdoor labor becomes dangerous for large parts of the year. Heat exhaustion would be the leading cause of death in equatorial regions. Soldiers, farmers, athletes, anyone exposed to long hours outdoors, would face limits not of strength, but of temperature. Whole professions might retreat indoors. The human body bends, but it cannot break physics. Two suns demand too much. So society must adapt in parallel. Not just individuals, but the cultures we build around them. The biological stress of two suns would bleed into every corner of civilization. What begins as exhaustion and burns becomes a cascade of health crises, cultural shifts, and new norms. Sleep deprivation turns chronic. Studies show that even a single night of poor rest affects memory and judgment. A week of it mirrors intoxication. Imagine billions living in a haze, struggling to focus, driving drowsy, making errors at work. Productivity plummets. Entire economies stumble. In response, nations might enforce mandatory darkness hours. Whole cities could dim their lights and lower shutters at agreed times, tricking their populations into a cycle that nature abandoned. Hospitals would overflow with heat-related illnesses. Dehydration, kidney failure, skin cancers. Governments would stockpile for fluids and cooling packs the way they once stockpiled grain. Insurance companies would calculate premiums based on how close you lived to the equator. Public health campaigns would sound like wartime propaganda. Hydrate. Cover. Rest. Culturally, the absence of night rewrites meaning itself. Midnight vanishes. Festivals tied to stars, like Ramadan's sighting of the crescent moon or the Hindu festival of Diwali, lose their context. Astrology collapses entirely. Constellations cannot be seen. Mythologies built on celestial cycles, Orion, Ursa Major, the Pleiades, turn into stories without reference points. Children might ask, "What's a star?" And parents would answer with pictures from dusty archives. The mental toll would be immense. Psychologists already document light pollution anxiety, in city dwellers who cannot see the Milky Way. Under two suns, humanity loses not just stars, but the comfort of cosmic scale. Without darkness, the universe feels smaller, and people feel trapped under a dome of endless light. Depression, anxiety, and existential unease climb. Society adapts in ways both clever and desperate. Work shifts invert. People schedule tasks during the rare hours when both suns dip below the horizon. Factories and schools operate at double dusk, a sliver of time when the world is dim enough to function without sunglasses. Entertainment adapts, too. Movie theaters thrive, not for the films, but for the darkness inside. Black-painted nightclubs market themselves as sanctuaries for the circadian rhythm. Vacations to dark resorts become a luxury, places where artificial night is manufactured with thick domes and soundproof barriers. Fun fact: today, dark sky reserves exist on Earth, remote places where artificial lights are banned to preserve views of the stars. In a two-sun Earth, the concept flips. Entire megadomes could be built as artificial night reserves, where people pay to experience true darkness for the first time in their lives. But inequality worsens. Wealthy nations engineer shade domes, underground transit, vertical farms, and blackout cities. Poorer regions suffer heat waves and famine. Already today, extreme heat kills far more people in developing countries. Under two suns, the divide becomes brutal. Survival itself becomes a privilege. The society that emerges is practical, adaptive, but uneasy. People endure, as they always do. But they endure in a world where darkness is rationed, water is wealth, and night is an artifact of history. Given enough time, evolution never sits idle. Humans, animals, and plants all carry the seeds of adaptation, waiting for the right pressures. Under two suns, those pressures arrive faster than ever before. Consider humans. Some individuals today are short sleepers, genetically able to thrive on 4 hours of rest. That trait, rare now, might dominate in a world where darkness is scarce. Within centuries, humanity could evolve into multiple chronotypes. Day-adapted humans who function under bright glare, and twilight-adapted humans who thrive during the brief slivers of dusk. A split species, not by race or nation, but by circadian rhythm. Skin, as mentioned, would darken across the globe. But perhaps new traits emerge. Natural reflective oils, denser hair, even pigmentation shifts in unexpected directions. Just as reindeer eyes change color with the seasons, human eyes might develop seasonal tints, or even dual pigments, allowing vision in glaring light without filters. Other species would evolve in tandem. Insects might shrink to reduce water loss, or burrow deeper to avoid constant heat. Rodents might become entirely subterranean, surfacing only when conditions allow. Birds might evolve smaller wings and more efficient flight to cope with endless activity. Fun fact: there is already an earth animal that thrives under punishing light, the desert locust. Under extreme sun and heat, it multiplies into massive swarms that strip landscapes bare. Under two suns, creatures like the locust might dominate, ushering in plagues of biblical proportions. Ecosystems could stabilize eventually, but into forms almost unrecognizable. Purple forests, silver grasses, nocturnal animals confined to domes of artificial darkness, human societies split by sleep cycles. Life endures. It always has. But it endures by becoming something new. His story of life under two suns is not only one of loss. It is also one of transformation. Plants turn violet. Animals abandon the stars. Humans engineer their own darkness. And evolution itself bends toward the light. But biology can only carry us so far. To truly survive, humanity must fight back with intention, not just adaptation. Technology, engineering, and strategy become weapons in a war against the sky. The question shifts from what happens to life to what can humans build to control it. Humans have always been engineers of necessity. We build fires in caves to push back winter. We build dams to wrestle rivers. We build satellites to predict storms. When the sky itself changes, when two suns rule the horizon, It is no surprise that humanity turns once more to invention. The fight against two suns does not begin in laboratories. It begins in cities. Skylines, once proud symbols of glass and steel, become liabilities under constant glare. Towers overheat. Windows act like magnifying lenses. Streets become furnaces. The first wave of adaptation is cosmetic but crucial. Cities learn to shine back. White paint covers rooftops. Sidewalks are resurfaced with high reflectivity concrete. Skyscrapers wear new skins, shimmering panels that shift color like chameleons, reflecting the brighter star at noon, the redder one at dusk. Fun fact: in Athens, Greece, a pilot project in 2010 replaced asphalt with reflective paving and cut street temperatures by almost 12 degrees Celsius. Multiply that across entire megacities and you glimpse humanity's opening move in this struggle. Not darkness, but reflection. Shade becomes infrastructure. Every new building sprouts awnings, louvers, or solar canopies. Streets once planned for traffic now double as corridors of shadow. Even highways acquire tent-like structures, their roofs lined with solar panels. People walk, not in the open, but through shaded tunnels, sheltered courtyards, and arcades. A city without shade is uninhabitable, and governments race to legislate minimum shadow coverage for every public square. Underground, another transformation unfolds. Subway systems expand not for transit alone, but as living space. Basement levels of skyscrapers are converted into residential blocks, offices, even schools. Some neighborhoods go entirely subterranean, linked by cooled corridors. Think of the underground cities in Montreal or Tokyo, multiplied by necessity across continents. Life retreats below ground, not as a temporary refuge, but as a permanent layer of civilization. But cosmetic changes and underground shelters are only the surface battle. The deeper war is fought in the atmosphere and beyond. Geoengineering, once dismissed as risky science fiction, becomes central policy. One idea is simple in principle, daunting in practice: shade the Earth. Scientists design orbital sunshades, vast sheets of reflective material stationed at strategic points between Earth and its suns. Each shade is the size of a small country, unfolding in space like a silver sail. Controlled by thrusters and computers, these shields deflect or dim sunlight before it reaches Earth. Fun fact: at Princeton University, researchers have modeled the possibility of placing mirrors at the Lagrange point, a gravitational balance spot between Earth and the Sun. Under two suns, this concept would be doubled, tripled, scaled to unimaginable proportions. Space itself becomes an umbrella. Closer to Earth, the stratosphere becomes a laboratory. Planes release aerosols, fine particles that scatter sunlight and create an artificial haze. On present-day Earth, volcanic eruptions do this naturally. After Mount Pinatubo erupted in 1991, global temperatures fell by 0.5 degrees for almost 2 years. Under two suns, humanity seeks to copy the volcano, not in ash and chaos, but in precision. Entire fleets of aircraft seed the skies to dim the blaze. But each intervention comes with risks. Orbital shades drift, tear, or collapse. Aerosols shift weather in unexpected ways. A cooling system for one region might trigger drought in another. The global debate grows fierce. Is survival worth gambling with the sky? Meanwhile, agriculture rewrites itself. Open-air farming becomes impossible across much of the planet. Instead, crops retreat indoors. Skyscraper farms rise in city centers, each floor glowing with LED light tuned to the exact needs of lettuce, strawberries, or rice. Hydroponic towers stretch like glass organs, pulsing with pumps and tubes. Today, vertical farms already exist in places like Singapore, Tokyo, and Newark. They feed a fraction of the population. In a two-sun future, they feed everyone. Traditional farms survive only in the far north and south, where sunlight is weaker and land still tolerable. The equator, once fertile, becomes barren. Genetic engineering joins the fight. Crops are rewritten at the cellular level. Rice that can photosynthesize at double intensity. Wheat with leaves that produce natural sunscreen. Tomatoes with skins tougher than ever imagined. Each harvest is not just food but data, proof that biology can be hacked to endure 2 stars. Energy, paradoxically, is the least of humanity's problems. Solar panels become supercharged. Under 2 suns, a panel farm in Nevada or the Sahara produces nearly twice the power it once did. Cities hum with electricity. Cooling towers, pumps, desalination plants, and vertical farms all run without fear of shortage. The bottleneck is not power, but adaptation. Energy is abundant, but survival is costly. And survival is unequal. Wealthy nations build orbital shades, underground cities, and genetic labs. Poorer nations, already scorched, struggle to keep water flowing and crops alive. The equatorial belt becomes a zone of collapse. Mass migrations streaming north and south, seeking cooler climates. Borders harden. Wars erupt over habitable land. Refugee caravans stretch for miles. Yet even in this chaos, humans innovate. New time systems emerge. Instead of day and night, people live by bright hours and dim hours. Work calendars adjust not to clocks, but to when both suns dip low enough for outdoor activity. Midnight vanishes. Noon multiplies. Entire cultures are built around surviving brightness, rationing shadow, and creating darkness by design. Entertainment adapts, too. Movie theaters and nightclubs flourish, not because of the stories or the music, but because of the dark. A cinema becomes more than a place for films. It becomes a sanctuary where melatonin can flow. Children grow up treating bedtime, not as the absence of light, but as a carefully manufactured condition, bought and protected by technology. Religions shift as well. Traditions built on the moon, the stars, or midnight lose their anchor. New rituals emerge around dusk, the fleeting moment when both suns dip low. Weddings, festivals, even funerals are timed to this double twilight, the only natural rhythm left. And then comes the question of expansion. If Earth is punished by 2 suns, perhaps the answer lies elsewhere. Mars colonization, once a dream, becomes an imperative. The red planet, already familiar with 2 moons, might feel safer than Earth with 2 suns. Humanity divides its efforts, adapt here or flee outward. But Earth remains home. And the fight continues. The story of humanity under 2 suns is not simply about suffering. It is about a species that refuses surrender. We paint our cities white. We build mirrors in orbit. We farm in skyscrapers. We invent night inside domes and helmets. We bend the sky to our will, not perfectly, not without cost, but with the stubborn refusal that has always marked us. 2 suns rise. And humanity rises too. Humanity's battle with 2 suns unfolds on many fronts. In orbit, in cities, in fields, and in politics. Every solution feels like patchwork, yet each one pushes survival forward another step. Let's look first at the orbital frontier. Orbital shields and mirrors. The idea sounds impossible, building umbrellas in space. Yet it becomes the defining megaproject of this era. Engineers imagine fleets of giant reflective sheets stationed at key points between Earth and its suns. Each one is hundreds of kilometers across, made from ultra-thin material, lighter than aluminum foil, but strong enough to withstand micrometeoroids. Fun fact: NASA once studied the idea of space sunshades, kilometer-wide disks at the L1 Lagrange point between Earth and the Sun. Even one shade could reduce sunlight by a fraction of a percent, enough to cool the planet. Under 2 suns, this project scales up to a constellation of thousands. The logistics are staggering. Space elevators are discussed, asteroid mining becomes essential, and robotic factories in orbit churn out reflective sheets like flags in a storm. Each shade must be guided constantly, nudged by thrusters to keep its angle precise. A misalignment could send beams of light ricocheting onto the wrong continent, turning cities into furnaces overnight. Still, progress continues. Humanity has always risen to the challenge of the impossible when survival demanded it. Just as the Manhattan Project raced to end a war, the Sunshade Project races to give Earth a chance. Sky engineering. Closer to home, geoengineering takes over the atmosphere. Fleets of planes release aerosols into the stratosphere, scattering light. It's like giving Earth a protective haze, a man-made veil. There's precedent. In 1991, Mount Pinatubo erupted in the Philippines, spewing sulfur dioxide into the sky. The result? Global temperatures dropped by about half a degree for nearly 2 years. Scientists measure this cooling as proof. If a volcano can dim the sun, so can we. But aerosols bring consequences. Weather patterns shift. Rainfall weakens in some regions, floods intensify in others. Farmers in one country may thank the skies while their neighbors curse them. The ethics grow tangled. Who controls the thermostat of the world? Whose clouds, whose rains, whose droughts are acceptable sacrifices? Geoengineering, in practice, is less like building a thermostat and more like balancing on a tightrope, adjusting constantly, nervously, never fully confident. Cities remade. On the ground, cities adapt visibly. White paint covers rooftops from Los Angeles to Lagos. Reflective cool pavements spread across Tokyo, Sao Paulo, and Mumbai. In Dubai, skyscrapers glitter not because of luxury but survival, each one wrapped in adaptive skins that change color with the suns. Shade becomes a civic right. Singapore builds kilometer-long shaded walkways between neighborhoods. Mexico City installs tensile canopies over public squares. New York mandates that every street corner have shade structures, the way hydrants once dotted blocks. Underground, whole districts emerge. Paris extends its metro into residential labyrinths. Toronto connects its path system into self-contained cities. Beijing carves out subterranean markets where citizens shop without ever seeing the suns. Living underground no longer carries stigma. It carries prestige, stability, comfort, protection. Public life also changes rhythm. Outdoor concerts vanish. Marathons shift into tunnels. Children grow up playing not in parks, but in cooled, shaded shadow domes. The word outdoors begins to mean something different. Not freedom, but risk. Agriculture's transformation. Food, the foundation of survival, undergoes its own revolution. The equatorial belt, once rich in crops like coffee, cocoa, and rice, becomes barren. Farms collapse under heat stress. Crops bolt, fruit rots, yields vanish. Nations dependent on agriculture fall into crisis. Meanwhile, vertical farms rise. In Singapore, towers glow pink at night, feeding thousands with strawberries and lettuce. In Chicago, old warehouses convert into hydroponic factories, stacked with trays of kale and herbs. In Tokyo, office towers dedicate whole floors to rice cultivation, grown indoors with LED light tuned to precise wavelengths. Fun fact: in Newark, New Jersey, an old steel mill has already been converted into the world's largest vertical farm. It grows leafy greens year-round, using 95% less water than traditional farms. Now imagine every major city on Earth doing the same, not as an experiment, but as the backbone of food supply. Genetics takes the rest of the burden. Scientists design wheat that can thrive under blinding light, tomatoes with skins thick enough to resist ultraviolet radiation, rice that grows in half the time. Even livestock feed is engineered. Algae farms replace soy, insects replace grain. The diets of billions change, not by choice but by mandate. Energy surplus, survival deficit. The irony of two suns is this: energy is abundant. Solar farms hum with power. A panel farm in the Sahara produces so much electricity it could light Europe for years. Battery storage, once a bottleneck, is solved out of necessity. The grid never sleeps, because the suns never sleep. Yet abundance brings little comfort. Cooling requires power. Water desalination requires power. Dome farming requires power. Humanity finds itself drowning in electricity, but gasping for survival. It is not energy that is scarce, but the ability to shield, feed, and cool. Geopolitics of shadow. No adaptation is free of politics. Nations fight over orbital shade rights. Should one country be allowed to dim the sun over its land if it redirects brightness onto another? Lawsuits become wars. Migration intensifies. Billions move north into Canada, Scandinavia, Siberia. The south flows into Patagonia and Antarctica, where ice retreats and land becomes habitable. Borders strain, collapse, reform. Refugee camps become megacities overnight. Fun fact: already today, Canada has one of the lowest population densities on Earth, with vast northern territories underused. In a two-sun Earth, Canada becomes a prime refuge, not because of resources, but because of latitude. Russia, too, holds cards no one expected. Land once frozen becomes farmland. The balance of power tilts toward the poles. Culture in the light. Even culture changes. Art shifts from paint to projection, designed to be seen under harsh glare. Music festivals happen underground, celebrated as dark retreats. Literature blooms with nostalgia for night. Entire genres emerge about starlight, the way we once romanticized lost golden ages. Religion, too, reforms. Some faiths declare the twin suns divine, symbols of testing and trial. Others declare them punishment, omens of apocalypse. New cults rise around twilight, worshipping the rare minutes when both suns dip at once. Humanity remakes its mythologies in the light of survival. Looking outward. Finally, the most ambitious response: leaving. If Earth is broken, perhaps Mars or Titan, or even orbital habitats offer escape. The technology developed to build sunshades doubles as technology to build colonies. Space stations bloom, not as research labs, but as lifeboats. The dream of space colonization, once slow, now accelerates. For the first time in history, leaving Earth is not an aspiration, it is a necessity. Two suns rise each day. Humanity responds with paint, mirrors, domes, genetics, politics, and rockets. It is not perfect. It is not even stable. But it is enough to survive. And survival, for now, is victory. But there is a deeper truth still to come. Even with technology, even with engineering, two suns are not just a technical problem. They are a cosmic lesson. A reminder that life thrives not only with abundance, but with balance. That reflection takes us beyond survival, into meaning. Science fiction has always been humanity's rehearsal stage. Before telescopes revealed the truth, before spacecraft sent back pictures, our stories tried the possibilities on for size. Two suns, twin skies. It was too irresistible an idea not to explore. Ray Bradbury touched it in The Illustrated Man, imagining alien families picnicking under twin shadows. Arthur C. Clarke's Rendezvous with Roma featured a cylinder-shaped world where artificial suns lit a hollow interior. Ursula K. Le Guin, in The Left Hand of Darkness, described not binary suns but the strange cycles of alien worlds, teaching readers to think beyond Earth's rhythm. Science fiction works not because it predicts accurately, but because it makes the familiar strange. And nothing is stranger, yet familiar, than the sun. Think of how deeply our lives are tied to it. Our clocks, our calendars, our myths, our agriculture, even our moods rise and fall with that steady blaze. Now double it. Two sources of time, two faces of worship, two rivals in the sky. It is the simplest alteration, yet it shakes everything. That's why storytellers love it. The iconic example, of course, is Star Wars. Luke Skywalker standing on a desert ridge, staring at a binary sunset. The music swells. He dreams of leaving his world behind. That scene lasted less than a minute of screen time, but it lodged in our imagination. For decades, if you asked people what a two-sun world looked like, they would describe Tatooine. Sand, heat, longing. What Lucas framed as myth, NASA confirmed as fact. In 2011, Kepler 16b became the first real circumbinary planet ever discovered. A gas giant the size of Saturn, orbiting two stars. The headlines wrote themselves: Tatooine found. Suddenly, the binary sunset was not just cinema, but astronomy. Since then, dozens more have been catalogued. Kepler 34b, Kepler 47c, and others, all orbiting dual suns, some in stable habitable zones. Astronomers now believe that binary systems may be the norm, not the exception. Fun fact: estimates suggest nearly half the stars in the Milky Way are in binary or multiple systems. Our single sun, so ordinary to us, may actually be unusual. In the galactic census, Earth lives under a rare arrangement, the COM of one star. Which raises a question: is our stability an accident? If life is common in the universe, most of it might exist under double skies, not single ones. The creatures of those worlds would grow up never knowing true night, never seeing the Milky Way, never tracing constellations. For them, our Earth might seem just as alien as Tatooine does to us. Science fiction has long prepared us for this inversion. Isaac Asimov's Nightfall posed the nightmare of a civilization that never saw stars until one catastrophic eclipse. The story, written in 1941, is often hailed as one of the greatest short stories in the genre. Its people go mad at the sight of darkness. On Earth with two suns, our story flips. We would be the ones going mad from light. Fiction warned us, only in reverse. Frank Herbert's Dune is another echo. Though Arrakis orbits a single sun, its merciless desert heat feels like a cousin to our imagined two-sun Earth. Shade is priceless. Water is holy. Entire cultures evolve not around plenty, but around scarcity of relief. Reading Dune is reading a manual for two suns. How humanity survives when the sky is merciless. Other works play with binaries more literally. In Poul Anderson's World Without Stars, humans discover a planet orbiting a dim binary far from the galaxy's core. In Anne McCaffrey's Dragon Riders of Pern, the red star disrupts life with cyclical terror. Again and again, fiction forces us to imagine light, rhythm, and instability in new forms. Fun fact: many of these writers had no data to work with. Astronomers once thought binary planets impossible, unstable, destined to be ejected. It was science fiction that kept the idea alive until science caught up. Today, science and fiction dance together. When NASA announced Kepler 16b, they leaned into the Star Wars comparison, calling it the first confirmed Tatooine. Outreach posters depicted vacation ads for binary worlds, slogans like, "Where your shadow always has company." Fiction made the science understandable. Science gave the fiction credibility. This interplay does more than entertain. It shapes research. The first astrophysicist to model stable circumbinary orbits admitted inspiration from Star Wars. The first engineers to propose orbital shades cited Arthur C. Clarke. The line is not as thick as we imagine. Storytelling teaches scientists what to try. Let's imagine further. Suppose intelligent civilizations do thrive under two suns. Their cultures would look radically different. Calendars could not be based on simple day-night cycles. They might measure time by alignments of the suns, by interference patterns of light. Their religions might worship rivalry or unity, twin deities locked in eternal competition, or a marriage of fire and flame. Their architecture would avoid glass, favoring stone and shade. Their art would be saturated with brightness, their poetry nostalgic for night they never had. On Earth, our myths reflect our sky. The single sun as father, the moon as mother, stars as guides. On a binary world, those archetypes double. Night itself becomes myth, a story told without first-hand experience. Science fiction prepares us to meet such aliens not with shock, but recognition. It reminds us that what feels alien may actually be common, and what feels normal to us may be rare. Fun fact: in 2016, astronomers found Kepler 1647b, the largest circumbinary planet ever discovered, as big as Jupiter, orbiting two suns not unlike ours. Its orbit takes over 3 years. If moons circle it, some of them might lie in the habitable zone. Imagine life not on the planet itself, but on a moon warmed by two stars. That is not fiction. That is possible physics. Cinema keeps pace too. Interstellar showed a world orbiting a black hole, bending time itself. The Expanse depicted asteroid colonies with artificial light cycles. Each story is a stepping stone. Each one accustoms us to asking, what if the sky were different? And that is the gift of science fiction. Not prophecy, but rehearsal. It does not tell us what will be. It trains us to imagine what could be, so that when discovery arrives, we are not unprepared. Two suns, once only an artist's backdrop, now exist in our telescopes. The line between dream and data narrows. Perhaps one day, Human colonists will stand on a real Tatooine, shading their eyes at a double dawn, and remember how Luke once did the same. In the end, fiction and science are not rivals. They are partners. Stories give us courage to imagine, and science gives us courage to try. Under two suns, we learn twice. Once from the sky, once from the stories we told before the sky changed. And that prepares us for the final lesson. Not what could be, not what is out there, but what our own single sun means here, now. We've imagined a world with two suns. We've seen the consequences, the adaptations, the struggles, and the triumphs. And now, as we return to our own single sun Earth, it's worth pausing to gather the lessons. Not just philosophical ones, but scientific ones too. Because science always rewards curiosity, and even imagination leaves us with knowledge. The first lesson is balance. Life exists here because Earth sits in a narrow band called the habitable zone. Not too hot, not too cold. Astronomers call it the Goldilocks zone, a name borrowed from the fairy tale where the porridge must be just right. But the math is more delicate than the name suggests. A planet orbiting 5% closer to the Sun than Earth risks runaway greenhouse warming, boiling oceans into steam. A planet 5% farther out could slip into a snowball state, freezing oceans solid. Fun fact: Venus receives only about twice the sunlight Earth does, but that difference was enough to turn it into an inferno. Its surface temperature is hot enough to melt lead, its atmosphere thick with carbon dioxide and sulfuric acid. Mars, meanwhile, sits just outside the zone, cold and barren, though once it may have held seas. Earth is not in the middle by accident. It's balanced on a knife edge. Now double the suns. That balance disappears. The Goldilocks zone shifts, warps, destabilizes. It reminds us that our position, so perfect for life, is not permanent, not guaranteed. We live in balance by grace of physics, not inevitability. The second lesson is fragility. We tend to think of Earth as enormous and resilient. But from space, it is a thin sphere wrapped in a thinner film of air. If the Earth were the size of a basketball, the atmosphere would be the thickness of a single sheet of paper. That's all that separates us from the vacuum of space, from radiation, from death. Fun fact: commercial jets fly at about 35,000 feet. Above that, you're already in the stratosphere, where breathing is impossible without pressurized cabins. The air we rely on is less than 20 kilometers deep, a sliver compared to the planet's size. Two suns would test that fragile shell beyond its limits. More radiation, more heat, more turbulence. And yet even without two suns, we are already altering that balance ourselves. Greenhouse gases thicken the blanket. Ozone holes let ultraviolet light through. The two-sun thought experiment reminds us how thin the margin is, and how quickly it can be undone. The third lesson is resilience. Life adapts. It always has. After the asteroid that killed the dinosaurs, ferns sprouted in the ash within years. After ice ages, forests spread back over continents. After nuclear tests in the Pacific, corals slowly recolonized craters. Life bends, it stretches, it mutates, but it endures. Fun fact: there are bacteria living in nuclear reactors, feeding on radiation itself. There are microbes 2 miles underground, sealed away for millions of years, still metabolizing. There are tardigrades, tiny water bears, that can survive in the vacuum of space, frozen solid, and come back to life when rehydrated. If two suns appeared tomorrow, life would not vanish. It would twist itself into new forms, as it always does. The lesson for us is that humanity shares this resilience. We invent, we adapt, we refuse to surrender. History proves it. The fourth lesson is humility. Astronomers now believe that binary and multiple star systems are not rare, but common. Our lonely sun is unusual. To most of the galaxy, double suns are ordinary, which means life elsewhere, if it exists, probably thrives under skies unlike ours. Fun fact: in the Alpha Centauri system, our nearest stellar neighbor, there are 3 stars: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. If a planet orbits in that system, its skies would be a dance of brightness. Our sky, with 1 sun and 1 moon, might look strangely empty to them. This realization flips the story. To us, two suns feel alien. But to aliens, one sun might feel alien. Our myths, our calendars, our constellations, all shaped by one steady star, could be as exotic to them as twin dawns are to us. The final lesson is gratitude. Every morning, our one sun rises. It arcs across the sky, and it sets, giving us day and night, rhythm and rest, balance and wonder. Every night, the stars return, thousands of them, stretching into a Milky Way band that binary worlds might never see. We inherit not just sunlight, but starlight, and we rarely pause to realize how rare that is. Fun fact: if Earth had two suns, the stars would be nearly invisible. The Milky Way, the constellations, the meteor showers gone. Sailors could not navigate. Astronomers would not dream. Poets would not write of Orion, of Ursa Major, of the Pleiades. The night sky, one of humanity's oldest companions, exists only because we have one sun, not two. When we imagine a two-sun world, we don't only imagine its difficulties. We rediscover our privileges. Night is not emptiness. It is gift. Science fiction asked the question, what if Earth had two suns? Science gave us the tools to imagine the consequences. And philosophy reminds us why we asked in the first place. We don't need two suns to learn. One is enough. Enough to sustain us, to challenge us, to inspire us. Enough to remind us that balance, fragility, resilience, and humility are already our inheritance. And so tomorrow, when the sun rises, one sun, not two, perhaps you will see it differently. Perhaps you will feel the weight of rarity, the gift of balance, the miracle of light. Because Earth doesn't need another star to be extraordinary. It already is.